Hello, I hope you're having a great day. I'm super excited to be here with you on your journey to maker greatness. In this lesson, we're going to learn about the Arduino's analog to digital converter and see how we can use the analog read function to read things like temperature sensors and other nifty devices. So this is going to be kind of a longer lesson, guys, but do stick with me here. And before we grab the Arduino or pop the IDE open though, I'd like to take a little side journey for a few minutes and talk about analog to digital converters, or ADCs, as we'll call them from here on, and how they work. Now, the way these devices work and the math behind analog to digital conversion can get really complicated. So we're just going to get a mile-high view of how they work and quickly mention some more common ADCs in use today, including the one the Arduino Uno uses. That way, when we hook something to the Arduino's analog pins and write code, we'll at least have a basic idea of what's going on behind the scenes. An ADC transforms analog information in electrical form into digital data. In other words, an ADC takes a continuous analog input signal and converts it into a binary number, which a computer or microcontroller can work with. Often, the analog to digital converters you'll work with are part of the microcontroller or board, as is the case with the Arduino. Analog signals continuously vary with time. So to convert an analog signal into digital form, an ADC must sample the analog signal at a certain rate or frequency. By sampling, we simply mean that we need to check the level of the analog signal every so often, whatever our sampling rate happens to be. And this sampling rate is governed by the Nyquist Theorem. The theorem itself involves a lot of heavy math, and it's kind of complicated, but here it is in a nutshell. The theorem says that to avoid any loss of information, the sampling rate must be at least twice as high as the highest frequency component we expect to see in the analog signal we're sampling. So you may be scratching your head asking, what does that mean? Well, let's say, for example, we're sampling a signal that has a frequency of 100 megahertz. Our sampling rate needs to be at least 200 megahertz to avoid losing information when we convert that analog signal into a digital one. And again, the reason this works is really complicated, so you're just going to have to trust me here. Now, some of you still may wonder what I mean by sampling. Let's have a look at some pictures that may help clear it up. Here we have an analog signal which is being sampled. The little sucker stick looking things are the samples, and the time in between samples is the sampling period. Now we have a close-up of the signal with the corresponding digital output on top of the analog signal. Obviously, this digital output's very rough, and we'd undoubtedly lose some information in the analog signal if we didn't increase the sampling rate. But notice how the digital stair-step looking signal sort of has the same shape as the analog signal there in blue. If we take more samples and reduce the sampling period, the stair-steps on the red digital signal will get smaller. If we continue to increase the number of samples and take them quicker, thus reducing the sampling time period, it'll get smoother and smoother until we can't see much of a difference, and it'll look more like the original analog signal. But at some point, we'll have increased the sampling period enough where no information will be lost from the original signal. The ADC on the 18MEGA328 that powers the Arduino samples the inputs of the analog pins in the same way to output a digital value. This sounds all fine and well, but what does all this have to do with Arduino? I'm glad you asked. Many of the sensors you'll use output their information in the form of an analog signal. Take the simple thermistor. Its output varies with temperature and is an analog value. Later, when we use the thermistor, we'll use the analog pins and the ADC. It's first worth talking a bit about the type of ADC the chip on the Arduino uses. And there's several different types of ADCs commonly used today, as I said, but the one on the Arduino is known as a successive approximation ADC. The successive approximation analog to digital converter is one of the more popular ones.